sklearnmetricsdetcurve. Description: the detcurve function in scikit-learn calculates the detection error trade-off detcurve for binary classification problems. The detcurve visualizes the trade-off between false positive rate (FPR) and false negative rate (FNR), or equivalently, between type 1 error and type 2 error. Inputs: y true, the true labels of the data points. This is a 1D array of binary labels 0 or 1 or a list of such labels. Y score, the predicted scores or probabilities for each data point. This is a 1D array of scores or a list of such scores. Higher scores correspond to a higher probability of belonging to the positive class. Outputs: FPR, the false positive rate FPR values for different thresholds. This is a 1D array of floating point values between 0 and 1. FNR, the false negative rate FNR values for different thresholds. This is a 1D array of floating point values between 0 and 1. Thresholds, the thresholds used to calculate the FPR and FNR values. This is a 1D array of floating point values. Steps: sorting scores, the function first sorts the predicted scores in descending order. Thresholding for each unique score in the sorted list. A threshold is considered. Calculating FPR and FNR for each threshold. The function calculates the FPR and FNR based on the predictions made by the model. Constructing detcurve, the FPR and FNR values are then used to construct the detcurve, which is a plot of FPR against FNR. Metrics: area under the curve AUC. The area under the detcurve is a measure of the overall performance of the classifier. A higher AUC indicates better performance. Visualization plots. Detcurve plot. The detcurve is typically visualized as a plot with FPR on the x-axis and FNR on the y-axis. This plot shows how the FPR and FNR vary as the classification threshold changes. Fine-tune parameters. None. The detcurve function does not have any fine-tuning parameters. Uncertainty methods. None. The detcurve function itself does not provide uncertainty estimations. Challenges and fixes. Challenge 1: imbalanced datasets. Sample use case that resulted in challenge 1 when dealing with highly imbalanced datasets where one class has significantly more examples than the other. The detcurve might not accurately reflect the performance of the classifier on the minority class. Fixes to challenge 1. Use appropriate evaluation metrics. Consider using metrics such as precision, recall, or F1 score instead of relying solely on the detcurve, especially when dealing with imbalanced datasets. Oversampling or undersampling techniques such as oversampling the minority class or undersampling the majority class can help balance the dataset and improve the performance of the classifier on the minority class. Challenge 2: non-monotonic scores. Sample use case that resulted in challenge 2. In some cases, the predicted scores from the classifier might not be monotonically increasing, leading to unexpected behavior in the detcurve. Fixes to challenge 2. Ensure monotonic scores. Check the output scores from the classifier and ensure that they are monotonically increasing or decreasing. If not, consider using a different classifier or adjusting the model's parameters to obtain monotonic scores. Alternative visualization techniques. If non-monotonic scores are unavoidable, consider alternative visualization techniques like the receiver operating characteristic ROC curve or the precision recall curve, which might provide a more accurate representation of performance.